Assalamualaikum. We are going to present our group project or report for static and dynamic. Our group member consists of Akmal Shahid bin Abdul Muttalib, Muhammad Syazwan bin Kamal Anwar, Nur Hafiza binti Muhammad Saleh, and me, Juliana binti Muhammad Sulaiman.
Firstly, I would like to introduce our introduction of our project. Our project consists of 5 different elements of civil engineering structure, such as beam, dam, bridge, roof, and beam column, were found for our project. The structure was studied and determined by analyzing their free body diagram, loadings, support, centroid, and moment of inertia. Each of the structure on site were recorded through picture, the material used, the function, the location, and the measurement.
For the objective, from this project, students will be able to determine the material and function of each structure used, learn how to draw free body diagram for different structure, learn how to estimate the action of or loadings on the structure, explain about the support reaction, learn how to find center of or centroid of the structure, and explain about the moment of inertia of the structure.
There are 5 elements of our structure, which is beam, dam, bridge, roof, and beam column. The first structure is a beam. Beam structure are an important type of structural element that construction professional and some types of engineers must be familiar with beam. Structure with overhanging, fixed, truss, continuous, and simply supported beam are the most prevalent. In construction, beams are used to tighten the columns, resulting in an ideal distribution of the bending force in the beams and a shorter amount of bending in the columns. Calculating the load being transferred to the beam to sustain the width in between them can also help define the length and width of the beams that are used. Calculating the amount of internal force acting on a beam yields its dimension. Next, I'm going to present the free body diagram of the structure. As we can see the figure showing the free body diagram being drawn. So the beam consists of 4 meter length times by a 23 kilonewton per meter. So we get a uniform distribution load of 92 kilonewton. The support reaction of the structure at moment A, as we can see on the slide, after being calculated, and all we get is 46 kilonewton at By and 46 kilonewton at Ay. For the centroid of the structure, it was calculated as in the slide. So for the axis, all I get is 2 meter cube, and for the y-axis is 0.2 meter cube. And lastly, the moment of inertia of the structure was found. So after being calculated, the moment of inertia at x-axis was 0.021 meter to the power of 4, and the moment of inertia at y-axis was 2.13 meter to the power of 4. As for the conclusion, further analysis show that the calculation for the body diagram, support reaction, centroid, and the moment of inertia has been identified that the structure which can last long for many years. The design is widespread in building and simple to build. The size of the structure has a crucial effect on the materials, strength, and durability of the beam, which is essential for a sturdy and secure structure in the building.
Next, I will talk about the dam structure. Dam is a structure that is built across a stream, river, or an estuary to retain water. Dams are built to provide water for human consumption, lands, or for industrial purposes. It is also used to increase the amount of water for generating electricity using hydroelectric power. Besides, it can reduce peak discharge of flood water created from storms or heavy rain and increase the depth of water in the river in order to improve navigation, thus allowing ships to travel easily. Dams also provide a lake for recreational activities such as swimming. Here is the free body diagram of the structure that has been drawn, and also the estimation of loadings and action to make us easier to calculate for the centroid and moment of the inertia later. I have calculated the support reaction that acting on this dam structure. From this calculation, I have got the AX value, which is 2400 kilonewton, and AY is equal to negative 1066.67 kilonewton meter. Here, AY is equal to negative BY. So the BY value is 1066.67 kilonewton meter. After that, I have drawn the structure for the dam to make it easier for me to calculate the centroid of the structure. For the centroid, I have got the X bar value, which is 32 meter, and the Y bar is 65 meter. And lastly, we need to calculate the moment of inertia of the structure. From the X bar and Y bar that we calculated earlier, we can find the moment of inertia at X and Y. At X, I have got the moment of inertia, which is 22.789 times 10 to the power of 6 meter power of 4. And for the Y value, I have got the 3.963 times with 10 equal to the power of 6 meter to the power of 4. In conclusion, the stability of the dam foundation has always been a great concern in engineering. Safety and durability is the most important objective for this project. Therefore, study needs to be done by the designer to ensure that the dam structure is able to withstand the loads and pressure of the water transferred to it. So, the support reaction, centroid, and moment of inertia has been calculated, and all the values are accurate for the Kenya Dam, which is used throughout this project.
Bridge is a device used to carry vertical weights that span or gap between the supports. The prototypical bridge is straightforward, consisting of two supports holding up a beam. But there are still inherent engineering challenges with every bridge. The support must be sturdy enough to support the structure, and the span between the support must be sturdy enough to carry the loads. Span are often kept as small as possible. Length span are only acceptable in situations when there are a few options for good foundation, such as over estuaries with deep water. So, this is the free body diagram of bridge and also the estimation of loading or action. Next, the support reaction we got is By equal to 40 kN and Ay also 40 kN. For the centroid, we got for X is 50 meter, while Y is 0.25 meter. Then the moment of inertia of bridge we got for ISX is 0.31, while for IYY is 1125. For the conclusion, based on the calculation of bridge, moment of inertia in x-axis is 0.31, moment of inertia for y-axis is 1125. The support of reaction can be considered the bridge is stable and has a strong enough structure because the value of support reaction is 40 kN. It is because a strong and stable structure is very important for this project. It can be concluded that the size of the structure is the important thing, especially for material, strength, and durability of the structure bridge.
Next structure is roof. Roof is a structure that forms the top covering of a house or other shelter and offers defense against weather. A set of structural components created to sustain the roof build-up typically makes up a roof structure. The trusses, beams, and rafters that make up the structure are what give the roof its shape and serve as the foundation for the roof sheeting. Depending on the requirements, they must meet the local temperature, the availability of materials, and labor and other factors. A roof can be built from a wide range of materials. A roof frequently serves as a weatherproof, stable, fireproof, soundproof, thermal, and acoustic barrier. The components utilized to build the roof is clay tile. So this is our free body diagram of roof and the estimations of loadings. This is the calculations for support reactions or acting on the roof. Next is calculation for centroid. So for x-axis we got 8.33 meter, and for the y-axis we got 6.67 meter. Moment of inertia for the roof structure is calculated. For x-axis we got 13333.34 meter power of 4, and for y-axis we got 8330.34 meter power of 4. The conclusion for the roof structure is, according to estimation, the values for the support reaction, central and moment of inertia have been computed and are logical and reasonable. The calculation leads us to the conclusions that the invention of the truss structure makes it possible to disperse the weight of a roof to the outside walls or columns for improved support. By supporting the loads of your roof, inclined vertical and horizontal loads, roof truss preserve the overall structural integrity of your roof. Triangles are created by joining horizontal and diagonal beams in trusses. Triangles are frequently utilized to create trusses because of how effectively they can support weight. Due to their strength, triangles are crucial when creating solid and secure buildings. So for the last structure that we are chosen is column and beam. The safe load path that is created to transport the weight and pressures on the structure to the foundations and into the earth is largely dependent on the use of beams and columns. Although beams and columns could be constructed from the same materials and shapes, they serve different purposes and have different designs. Beams are typically horizontal structural components that support loads parallel to their longitudinal axis. In order to transfer the load to a vertical load bearing element of the building, beams are utilized to carry the weight of the building's floors, ceilings, and roof. To support the combined weight of stacked walls or other beams and transfer the load to the supports, larger, heavier beams known as transfer beams are occasionally utilized. So this is the free body diagram of the column and beam, and also the estimations of loadings. So this is the calculations of support reaction acting on the column and beam. Next is center of the structure is calculated. For x-axis we got 10 meter and y-axis we got 6.78 meter. Moment of inertia of column and beam is calculated. So this is how we calculate the moment of inertia. So for x-axis we got 628.46 meter of power of 4, and y-axis we got 3936.01 meter power of 4. Lastly, for the conclusion of column and beam, further investigation revealed that the calculation for the body diagram, support reaction, central and moment of inertia had determined that the building's beam and column construction is stable and logical with the ability to last for a very long time. This can also be interpreted as meaning that we must use a stable material and an acceptable construction, as these are the main elements that will determine the stability of the building. The use of static and dynamic analysis is crucial in civil engineering since it allows us to determine whether a structure is safe and make the determination.